All's well. We're live now. Uh, so, uh, First of all, welcome to already listening. This is going to be all new, so everything that goes wrong will be noted for next time. Tony at Hackenslash one asked. Oh, wait a minute. See, and things go wrong already. I had my own live stream running. Tony asked me to do a chat, and we decided to chat a bit about cosmology, which is great because I don't have a clue about that. So all I can do is learn. If all is correct, we'll have a chat. So if people want to leave a message, please do. Uh, so Tony, welcome.
And to you too. Nice to have a chance to chat again.
Yeah, that's mutual. Uh, so, cosmology. You said you wanted to clear up a couple of where do you want to start?
Well, I think that the important place to start is the biggest misconception about cosmology is that we have this idea that the universe definitely had a beginning, and there are all sorts of attendant things around that kind of people have latched onto. That's a very outdated idea of cosmology. It's probably about 40 years out of date, but it's still the one that sort of is prevalent in the mind of the public. Um, so I always find myself when I get into any discussions with theists, for example, or with people who discuss with theists, I always find myself going in and correcting some of those misconceptions just from the start, because you can't. I think a lot of the problem I have is that people who share my position and argue those points are actually undermining their own position because they've not really got the factual content. And it's a bit difficult as well because even a lot of physicists, you'll hear Brian Cox say, "Oh, well, time began at the Big Bang." There's no justification for that idea at all. So these are the things that you have to try and clear up misconceptions about, and of course people are very resistant to those corrections because they're part of the part of the mainstream understanding as they see it.
Hmm. Well, my thoughts, at least about it, think that we can say that it had a beginning. If there was a singularity, it to me it looks like it's more like a transition than a beginning.
Yes.
Am, am I correct in thinking that way?
Well, yeah, and the other thing is that the um, part of the problem, I think, is how we use terms and how they're defined. For example, we say universe, and most people think everything there is, all there is. And even physicists use the word that way. But then there's also the broader sense in which what we experience, our local iteration of the universe, may not be all of it. So I've always drawn a distinction between the universe, which is the one thing, and the cosmos, which is our iteration of it. Then, of course, it turns out that a couple of years ago, I discovered that a convention has arisen since I've been talking about this, where the cosmos is the broader one and the universe is our local one.
Yes,
and
that was my understanding too. So
yeah,
um,
and the other thing is the singularity. The singularity is a big problem, and some of that is about the definition as well, but some of it's about what we can actually say and what science says about the singularity. So I suppose the most important misconception there is to deal with what a singularity is. So in scientific parlance, what a singularity is an event that our theories can't describe. Basically, it's where our theories break. In the case of sort of cosmic singularity, a Big Bang singularity, and black hole singularities, what they're actually talking about is once you get beyond the event horizon of a black hole, for example, we really don't know what goes on. In order to find out what goes on, we need a quantum theory of gravity, and we don't actually have one yet, because once you get down below a certain scale, when you try to make general relativity, which is our theory of gravity, and quantum mechanics, which is our theory of very small interactions, then you get, when you try and put them together, you get solutions that are infinite. And it's popularly thought that if you see infinity in the solutions to your equations, you've done something wrong. That's not actually the case. Physicists use infinity all the time. However, in this case, because you're talking about a quantum theory, all the outputs are probabilities, and a probability can only ever fall between 0 and 1. So an infinite probability is a nonsense. That's why it's a problem. So we have this point where our theories simply can't go there. We don't know what goes on there. We have no information. We don't even have any theoretical model really that deal with it in any detail. String theory is the nearest, but it's very, very difficult for string theory to make contact with experiment, which means we're still looking around trying to derive consequences of strings in a way that means that we can make some contact with experiment, and that's very, very difficult because of the scale. In order to get down to the sort of the sub-Planck scales that string theory deals with, we'd need a particle accelerator about the size of the solar system, and that's not going to get built anytime soon.
No.
So the other definition of a singularity.
What I'm curious about is when we talk about black holes, it's difficult to grasp, but could physics be different in a black hole than in the rest of the universe?
No, not really. It could be that there's new physics that we haven't discovered yet, but I think it's. I think let me circle back to that because there's I don't know. Let me think about that for a minute. The other definition of singularity, which is the idea that most people have of what a singularity is kind of this physical thing where there's lots and lots of mass in a very, very tiny space, and that it's a region of infinite density and infinite curvature. Now, this is a problem because quantum mechanics says this can't exist. It's an asymptotic value, and you know what an asymptotic curve is, yes?
No.
Right. Okay. So you'll have seen, no doubt, graphs for. Well, you'll have seen graphs for all sorts of things, curves, where you'll see a curve that curves in such a way that it gets very, 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 very close to a line. It gets closer and closer and closer, but never actually reaches it. Yes.
Yes.
That's what an asymptote is.
Okay.
So that's what a singularity is in quantum mechanics, that physical notion of a singularity. So quantum mechanics says that a singularity can't actually exist. And actually most of our current understanding is moving away from singularities, and has been doing for quite some time under that definition of singularity, which is a popular notion. And the other thing is, and of course, because of general relativity and because of the Hawking-Penrose singularity theorem from 1970, and that's why I say it's 40 years out of date, because that's how old this theorem is. So their theorem said that if general relativity holds at appropriate realms, then the universe must wind back to a singularity. However, we know that general relativity doesn't hold. It's not complete and can't describe those events. Therefore, we have to reject the singularity theorem. But people still cling to it. But also, because of that, because that if you think so, a black hole, it's easier to simplify if we go to a black hole because the singularity applies there as well. So as you cross the event horizon of a black hole, time stops, and the reason that time stops is because escape velocity is greater than light speed, and if you're traveling at light speed, you don't experience time. So photons, for example, don't experience time. We see little particles, but they experience their lives as a line. Yeah. Mm-hmm. Because all of their journey takes place at the same time. They don't actually experience time. Yeah. Does that make sense?
It's for me, it's a lot to wrap my head around.
Right.
To be honest.
So anyway, yeah. So, but the simple sorry, go ahead.
Oh, go ahead.
Right. So the simple notion is that if you're traveling at light speed, time stops. Yeah. And the corollary of that is because immersion in a gravitational field and acceleration are equivalent. That's what the equivalence principle of general relativity is. Then essentially you're being accelerated at light speed, which means that time stops. So this is where we get the notion that time began at the Big Bang. But in reality, if you think about it, that's only our iteration of time. If you wind it back, and even if there was a singularity, it doesn't necessarily mean that there was no time before it. It just means that the singularity didn't experience it. Does that make sense?
Yes.
Because we can point to things now. Yeah, we can point to things in the universe now that don't experience time, but clearly time still exists. Yeah.
Yes, I think it's even better. I'm getting a huge echo now, Tony.
Yeah, yeah.
I think this is terrible. Can you get a headphone?
Are you struggling with the audio on my end?
Yes, I'm getting a huge echo of myself.
Oh right, have you muted the stream?
No.
So have you got?
Yes.
So you've muted the stream on the YouTube page.
Yes. I'm getting an echo from you, I think.
Oh right, okay. Probably because I'm using speakers. All right, let me see what I can do. I shall try something else. Maybe
okay. It wasn't that loud at the start, so I don't know what happened there.
Right. Okay. Let me just. It's looking like.
I think it's a bit like a game show we had where people had to sing while hearing themselves back just a part of a second later. And
right.
It completely.
Yeah. Latency. Yes, it's something I have to struggle with in the studio all the time. Right. Okay. I think we're. Okay. How's that?
I'll have to try. This is much better. Echo is gone, so
fantastic.
That's good.
Okay.
Where we were, the fact about time before the Big Bang.
Yeah.
If time, at least to me, if time started in the universe at the moment of the Big Bang, that could be the fact, but to me at least, that there would be a probability that outside of the singularity, time could have existed, because it's a difficult thing to wrap your head around, that there is no time.
Yeah. And if you think about it, I mean, even from a purely philosophical perspective, what we can't even formulate questions about a beginning to time that don't run into problems. Because, for example, how could there be a before? How could there even be a beginning? That you know, for there to be a change, there has to be a passage of time. Things, you know, so
Yes.
We can't avoid temporal language because it's embedded in the way we think about things, and I think that's the real problem.
Yes, that's what I think too. I think the theists would love the fact that there was time before, because that to them would automatically mean that God is possible, and
Yeah.
On the other hand, it would be a problem because God is outside of time. So now they have another problem.
Oh,
If
look,
time did exist.
have you noticed where atheism has joined us under the name eCantona7, my favourite footballer ever, well, apart from Paul Scholes, and he's commented, "Someone call a sound engineer." I've got news for you, mate. I am a sound engineer.
Yeah. So I think we have the sound covered now. So
yeah,
you
I think
know
we're all sorted now.
eCantona7?
Yes, he's We Are Atheism on Twitter.
Okay. Oh yeah,
Yeah.
he said that in the chat. Yeah. So but the singularity, what I conceive it as is, if you look at molecules, they mostly are made up of nothing, of air, of yes. So what if we were to take that away and to compress it? I think that could be some kind of an explanation of a singularity, maybe. It's
certainly, and that's really where the idea of a singularity comes from. But there are deep problems with the idea. As you get, I mean, really, we know from astrophysics that, for example, when a star that's more than about 1.4 solar masses, i.e. 1.4 times the size of the sun, the mass of the sun, that when they collapse, and when they run out of fuel and they collapse into a neutron star. So this is a star that's basically mostly made up of neutrons, and it's held up after that point by what's called electron degeneracy pressure, which is a function of the Pauli exclusion principle. Once you get over a certain mass, though, they will collapse even further into a black hole. Now, the singularity is still the point at which our theories can't go there. We have no idea what's going on there. So all of the things about the physical notion of a singularity are pure speculation. We have no model that can actually describe a singularity. We have general relativity, which says that singularities of that nature can occur. But on the opposing side, we also have quantum theory that says that they can't. And in order to put them together, in order to get a quantum theory of gravity, we have to have a theory that renders sensible solutions, and an infinity in quantum terms is not sensible because it's probabilistic. So it always comes back to the same problem, that our best theories disagree with each other on this point. We know that the realm of applicability of quantum mechanics is far greater than that of general relativity. That's why most scientists think that it will have to be it'll have to be general relativity that's modified to account for quantum phenomena. There are a few physicists, notably Roger Penrose, among a few others, who think that it's quantum mechanics that'll have to be modified. But the simple fact is, we know that quantum mechanics applies at relativistic scales. We just can't get the reverse to happen. So we don't have a theory of gravity that goes down that far. Does that make sense?
Yes, and Also, I think since we haven't explained gravity,
Yeah.
because that's still a problem.
Yes, and
How that works.
gravity is how the singularity would have to come about. So we need a quantum theory of gravity before we can say anything about it, really.
And something, it might not be possible, but something I've thought up is, what if a black hole is just maybe the next singularity for another universe?
It is something that's been thought about, and it's certainly a possibility that I mean, another universe. It's difficult for us to talk in these terms now, but string theory, for example, says that there are 11 dimensions in total. Now, what another universe would be in that sort of setting is, for instance, under string theory, all these dimensions exist all the time, but they're compactified, yes? They're very, 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 very small, which is why we can't see them. So if you think of a dimension as being a degree of freedom, yes? So there are 11 degrees of freedom. It's possible that there are 2 of time. But it's difficult for us to visualize, because it may well be that time is just a spatial dimension, but we experience it as flowing in one direction only, because we can't cope with the idea of there being 4 dimensions. If there were 4 spatial dimensions, of course, we wouldn't be able to exist, or if there were 2. But so the idea is that all of these are compactified. The Big Bang, or the expansion of our universe, is simply the expansion of 3 of those spatial dimensions and 1 of time. So it's possible that when a black hole collapses, when something collapses into a black hole, what actually happens is all of that mass goes down, comes together and actually expands other spatial dimensions. Yeah. So basically, the stuff that's taken out of our universe via the black hole just opens up in another 3 spatial dimensions elsewhere, and it may even be that some of those dimensions are shared with us.
Yes, but
so it is something that's been. Lee Smolin wrote a book that's really quite interesting on this, and he came up with this idea of fecund universes. Universes that are fecund means highly reproductive, so they have high rates of reproduction, and that what actually the universe is fine-tuned for is the production of black holes, and that these black holes are the pinching off of other universes, and these other cosmic expanses are simply, we live in this kind of bulk of cosmic expanses, and that ours is a black hole from another universe. So it may even be that we're embedded in somebody else's spatial dimensions as a universe.
yes, but
Good, isn't it?
It still is something that's completely I'd say almost impossible for us to grasp, because we're inclined to see the world by things we see, and it's very difficult to imagine something that you don't actually have an example for.
Yeah.
Same thing goes for nothing. We don't have an example for nothing, which is something people are attacking Krauss about, because he explains it in different ways.
Yeah.
But we don't have an example for that, and so I think just the concept of nothing is incredibly difficult to explain to people, or to even wrap your head around, because there's no example. And I think that's the same, at least for lay people like me. When it comes to a black hole, um, it's difficult to imagine what would happen in a case like that. What would happen to matter? What would happen to time?
Indeed, and I mean, part of the problem with Krauss and the flack that he took is that people read the title and didn't read the book. And this
Yes.
is something I've talked about at some length. Not only the idea of reading the title and not reading the book and thinking you understand everything that's being talked about. What he's actually saying in the book is not that the universe came from nothing, although that there is a sense in which that's true. He's not even saying this is how the universe came about. What he's saying is here is a plausible mechanism, and more importantly, there can't ever be any such thing as nothing in the sense that people think of nothing. It can't actually happen.
Yeah. It's something I had huge fights on Twitter about. People keep claiming that what he actually said was the universe came from nothing.
Yeah,
and then when I tried to point out that he just came up with a plausible explanation, is something they refuse out of hand, because all they know about Krauss is that some theist made a video about something Krauss said, or a speech he made, or whatever.
Yeah.
And just taking uh, uh, just listening to a couple of minutes, I think, skipping over the talk, and not even registering what he is saying.
Yeah.
And so that's something I've come across a couple of times now.
Yeah. Yeah, and what he's actually saying is that we have a mechanism here, Heisenberg's uncertainty principle, that's responsible for stellar fusion. It's what underlies the technology that we use to communicate daily on a daily basis. That this uncertainty principle gives us a way by which all that we see can come about from the nearest thing to nothing that we can tell is possible. And in actual fact, Heisenberg's uncertainty principle, and it's because Heisenberg's uncertainty principle underlies everything, that we know that nothing is simply not possible. It cannot happen. It can't persist. It's certainly the case that the fields that pervade the universe can all have a zero value, and that would be nothing, literally nothing of any kind. But it can't persist. And when we talk about fields, people say, "Oh, well, the fields are still there." Well, are they? What is a field? A field is a notion of a value of some parameter changing throughout space. But so if the value of the field is zero, what's there? Nothing.
Yes. Well, I tried to explain that because, as far as I'm aware, the energy count of the universe is zero. Is that correct?
Correct. That's correct. Yes.
Okay, so that would be nothing. And the way I try to explain that to myself is pretty much the same you have when you look at your money in the bank.
Yeah.
You can overdraw, let's say, $100 or £100 in your case, and have 100 in your pocket.
Yeah. But there's still minus 100 in the bank.
Yes.
So the value of that field sums to zero. Exactly. Then that's a great analogy. I tend to use a rubber band, simply because it's you can think of the universe as being a stretch. So if you take a rubber band, it has zero stretch, and then you stretch it and you create a gradient. You create an energy gradient, a differential that wants to equalize. And that's essentially that's what entropy is. In fact, entropy is just all the energy in the universe trying to equalize, trying to get to its lowest energy state. And it does that by various means. But if you think about the stretch, you still have to pay back that stretch. And we know, for example, that virtual particle pairs pop out of the fabric of space-time all the time. Now, what they actually do is create a differential, and it's exactly the same as you're putting money in you're taking money out of the bank that you don't have. It's exactly the same thing. So that's actually that's a really great analogy, and I think I might use that. I might use it and expand on it if you don't mind.
Sure.
That's it, because that is a cracking analogy.
Yeah, well, what I found on Twitter, and it's basically something I took over from Kent Hovind, actually, because everything he does has to be explainable or comprehensible to I don't know what he says, an 8th grade public, I think, which I think is necessary if you talk to some of the theists on Twitter, people that are homeschooled. They tend not to grasp a lot of things. So if you without being insulting, but if you dumb it down a little, then at least you can have a conversation. And
yeah,
if you don't, you'll lose them, I think.
Yeah.
Well, and that's why I thought of that analogy, because to me at least it makes sense. If you can have nothing and still have something.
Yeah. What I would say, I notice we have a question that wants answering in the chat. What I would say about that is that I don't talk to creationists, and it sounds a really strange thing to say, because you see me interacting with creationists on Twitter all the time, but in reality, I'm not talking to them. All I'm ever doing, and in actual fact, it's the motivation for my blog, and it's the motivation for all the talks I have and so on. What I'm usually doing is trying to provide those who are on my side of the fence, as it were, with the very best arguments and information. So really, what I'm doing is I'm talking to the other people in those threads. I'm using the creationist comments as a launching point for correction. And sometimes you know yourself, sometimes I'll jump in with a correction of something that somebody on my side of the argument has said that I think is worth correcting. But generally speaking, I'm not talking to the creationists at all. Simply because I know from well over a decade of experience in these conversations that if you change the mind of a creationist, it's a fluke. In reality, all you can do is just keep chipping away. If you're actually trying to convince a creationist that you're correct, you really are wasting your time and you're doing it wrong. That's how I see it anyway. So I'm always going for the audience. I'm trying to dilute the crazy, as it were, with especially with you get the odd fence sitter, you get people who will be convinced who aren't necessarily involved in the discussion. And of course, I know from years on forums that people lurk a lot and just read. I've had comments on Twitter from people who follow me on Twitter who I discover have been reading my stuff on forums for years and years and years, and have commented that they're really glad to see me on Twitter now because they've been reading me on the forums, on the all rationalist forums for years.
Yeah, so I think it's a chain. The reason I went on Twitter was just to counter creationists, and I'm fully aware that I won't be the person that'll change their mind.
I wouldn't say that.
At least for now, not the people I've talked to so far. But if I can make just one think about his or her position, then I think my work is rewarded enough.
Well, actually, to tell you the truth, I think that you do something that not a lot of people are doing, and it's valuable, and I think that you should be lauded for it, and we need to get more people sort of watching your stuff, because what you're doing is you're having open conversations with people that the rest of us are kind of dismissive of. For example, somebody wanted to goad me into a debate with Kent Hovind, and I said I'll happily do it. He's gone completely silent since then, of course. But for me, it's not. I'm not massively interested in having a discussion with Kent Hovind. I know what he's going to say. He doesn't know what I'm going to say. But I think anybody who would watch that debate, they're only going to watch it to get some entertainment out of it because they think I'll marmalise him. And they're right, of course. But I think that the discussion that you have, that the fact that you're sitting down and discussing openly with them, is something that's to be encouraged, because having that sort of conversation and people seeing that sort of conversation, that they can see that actually there are other approaches. I like ridicule. I have to say, I've always been a fan of ridicule when faced with the ridiculous. So I tend to that.
Well, I think I do that too every once in a while, because you can encounter someone who's well, I can name one, a guy I'm following, Daniel. I had a talk with. I need to post that, because I think he's so far off. He believes.
Is that DCJ Daniel?
Yes, I think so.
Yeah, I've come across him. We're atheists and asked a question. I think we should probably pop that out of the way. If chaotic random quantum fluctuations have always existed, they'll inevitably cause the universe, yes or no? I would actually say they are the universe. That it's inevitable that something exists because Heisenberg's uncertainty principle exists. There can't ever be nothing. And in actual fact, Frank Wilczek, Nobel Prize winning physicist, calculated, actually put a probability figure on it. It's not inevitable quite. It's something like 60%. So 0.6 probability that the universe will arise, that something has to exist. It's deeply improbable that nothing would exist. So I hope that answers the question.
Okay, I'll answer one too, because I saw Renee come on.
Renee's just come on, yeah.
I like Tarsius. Renee says you can get them to think, and sometimes you can't even do that. I don't think so. I recently discovered Sandra, who was known as Plato Poem. I don't know if you're familiar with her.
No, it doesn't ring any bells.
She was a young Earth creationist and started writing a book and even publishing the book.
Yes. I haven't interacted with her much, but I did see some exchanges on that.
Yes.
Yeah, and she changed her mind in the course of writing the book, didn't she?
Well, she changed her mind. An atheist set up a forum for her to have a discussion. Just him and her on the forum. That's at least how I thought it happened. Right. And by doing that and allowing her to ask any questions and him explaining, he changed her mind. which left her with 5,000 copies of the book that she can't sell anymore because uh, she doesn't hold the position anymore and
Yeah.
doesn't want uh, to leave it out there,
Yeah.
which I think is a tremendous uh, amount of courage to
Absolutely.
to because it left her in financially uh, in a very bad spot. She had she saw the money she put into it just vaporize, and
Yeah.
is still struggling with that. And so
I would say that's a
that
small price to pay.
it is maybe a small price to pay, but it is a huge price for an individual person to pay. And
Yeah, it is.
to I think it's only commendable to say that it takes an enormous amount of honesty if you're in that spot and you have invested not only an enormous amount of time, but also a lot of money to change your position and to take your loss. That
Yes.
that to me is something. That's why I'm very eager to talk to her. Um, she agreed to do a chat, but is not quite ready to do one yet, and I have to respect that.
Yeah.
But I'm I'm very happy. I at least met her on Twitter and got a chance to talk to her. I talk to her regularly via a DM and sometimes in the open. So um, people can change their mind, and
Yes.
the reason I started doing what I'm doing is to maybe try and get the animosity out of the way, which I think is not helping if you want to convince people of what's real and what's not.
Yes, absolutely. And I think the other thing to bear in mind is that um, even though we might not see the results all the time, I know for a fact I'm into double figures for deconversions, from full blown creationist to atheist, just over the course of discussions. But I also know that some of the ones who haven't listened, you've planted a seed, and that
Yeah.
seed is going to niggle away at them.
Yes.
In a lot of cases, that seed will niggle away at them. I do think, though, that it takes one person is rarely going to be able to do the entire job, but you can plant the seed, and that seed will take hold and come to fruition eventually.
Yes, and that's what at least what I'm in for. If I can just make someone think, that's the first step. And yeah, as you said about ridiculing, I still struggle to take on the flat Earth community because I think that's an amount of
Ridiculous.
stupid that I still have trouble dealing with. Um,
I think much of the problem is that they come from the same place. Flat earthers tend to be creationists, and it's because they have this literal exegesis of the Bible, and that they have to, the dome of the sky, and and all of this nonsense, and it is all biblical. And I think it's very difficult to sort of put a dent in that, and especially when you see pictures from height where they can't see the curvature of the Earth, or where you can see it, they'll say, "Oh, that's because of the fisheye lens," or something like that. When in actual fact, the horizon is always going to be the same distance away in every direction, no matter how high you are. And
yeah.
because you have to get a lot higher than any of these photographs get. You have to get out into space really to see the curvature. Um,
Yes, but
Horizontally.
do you? I think
Well,
it's to me at least it's pretty clear that if you go to the sea or the ocean, um, you can see how the ships disappear from
yes,
sight. So
yes.
that's
I did say horizontally. So on your eye line, the horizon is always going to be flat. So you will see something disappearing over the horizon, but you can't actually see curvature along the horizon horizontally, if you see what I mean.
yes, but that's a simple way of checking it. And
Yeah,
what I don't get is how they get by that. Um,
absolutely.
I don't they talk about that it's perspective, but perspective doesn't work that way. It doesn't conceal the bottom half
No,
when things are at a distance.
no, it doesn't. And actually, because of atmospheric refraction, it works the other way. The atmospheric refraction will mean that you can actually see slightly over the horizon. So that's why when the sun goes down, it seems to take ages, even though it's moving at the same rate. When it gets down towards the horizon, because of refraction, it looks bigger and it takes longer to. It seems to slow down, and that's all because the refraction is bending the light around the surface of the Earth.
Yes, and so that's still something uh, I have trouble taking that serious because
Yes.
it's so terribly ridiculous to me that people can even think that, and in a time where we have actually photographs of Earth showing that it's a sphere,
Yeah.
and
So,
then
yeah,
you have to have a massive denial of everything uh, that that we know so far, everything at least NASA put out, and that's where I don't get it. That people
no,
want to be that stupid and want to deny all of that.
yeah, no, I fully understand, and it's part of the reason that I write the stuff I do on the book. I try to only address a topic once if I can, um, and so that's part of the reason that I write the articles I do on the blog. It's to counter the deepest of the stupid. I don't know how much of my blog you've read.
I have to say it's for me it's time. I've read a couple of things
Yeah,
over time, and I whenever you do a massive retweet, I try to pick out something.
yeah,
But time is a serious issue for me,
of course.
and I tend to get hooked up on Twitter, and at now it's getting busy because it's not only um, people replying to tweets, but a lot of DMs as well. So it's
Yeah,
very difficult. I'm struggling to keep up with our DM group, and I'm
yeah,
in two of them, and I
yeah.
struggle on both. So yeah, time is an issue for me.
Yeah, indeed. I note as well that my notifications, I try to get through them, but the thing is that whenever anybody comes across anything stupid now, they tag me into it to see to see what I have to say about it. You know, any creationism, flat Earth, UFO, moon landing, bollocks. Lots of people tag me in, and I like it, and I do try and look through it, but you can't get through it all.
No,
And I
and
know,
that's
for
and that's
example,
and that's why I like to have a one-on-one conversation, which is uh, pretty difficult on Twitter because people will jump in,
yeah,
and but I like the one-on-one conversation best, and that's why I use the quote tweets a lot, because that filters out others jumping
Yeah.
in. I don't mind people jumping in, but I would like that if they jump in, that they untag me and have their own conversation, which I can follow. Um,
Yeah.
and
Yeah.
that,
Rene's pointed out that Rene's pointed out that he suspects that at least some of them aren't really serious, and he's probably right on that. Some people just jump on the bandwagon to troll.
yeah, but there still are a lot of people who really think so, and
Oh yes, indeed.
at least in America, it's getting uh, quite a foothold at the moment. When
Yeah.
when even famous people come out as being a flat earther, I think you have a serious education problem on your hand.
Yeah. Yeah. Well, that's a good question. Is
And
it any more ridiculous than believing in a resurrection? Actually, I wouldn't have any problem believing in a resurrection. I don't think it proves divinity anyway. Um, I think a resurrection would be extremely unlikely, but Heisenberg's uncertainty principle can take care of that again. Still, you know.
and there still are people that seem to wake up after being declared dead because they
Yeah.
aren't actually dead, and I think that also is a good probability to maybe what's the origin of the story. I still am in the camp that Jesus never existed. Um, there
I
are
find that difficult, to be honest. I get that that the evidence is very scant, that there isn't really anything outside the Bible, but there are aspects of that. Richard Carrier tells me that he's addressed this, but I haven't actually checked out his refutation of it. But for me, there's the principle of parsimony always has to apply. So you always have to say, right, what is the most economic solution here? So if you look at the whole nativity story arc, there's an awful lot of engineering to get this person to the place where he's supposed to be born to fulfill the prophecy. If you were just making the character up out of whole cloth, why would you even bother? Just have him born there. So that
yeah
aspect of the story, it seems to me, it's more economical that there was some person called Yeshua who existed and to whom these stories were attached. A bit like King Arthur, because we know that there was an enforcer for the Romans who came to Britain from the steppes of Russia, and his name was Arturus. And he sort of stayed around after the Romans left in the 5th century, and has has had all these local legends and myths attributed to him, probably because he went around the country a lot, and
well
putting down uprisings and things.
well I think I'll have to clarify that my position a little bit. I think that there probably was a guy named Yeshua in that time, but the stories attributed to him,
Yeah,
uh,
bollocks.
yes, not only that, most of them are uh, known stories about different gods. If you look back, you have Mithras, you have
Yeah,
Egyptian god. I'm not sure. I think it was Ra, who has pretty much
Horus, I
this,
think.
or Horus, yes, the same attributes as Jesus had, and it's just too much coincidence. And I think if you look back in later time where the Catholics have adopted Christmas
Yeah,
just to get the pagans on board, I think it's very reasonable that with Jesus they did exactly the same, and pound on the attributes of known gods to uh, maybe get people over to Christianity.
yeah,
And I think that's a lot more plausible then
yeah, I agree. There's an interesting strain of conversation going on in the chat at the moment. Have you seen it?
no, because I have to look at a different screen.
Oh, right, okay. So We're Atheism has interjected. Well, they're talking about the resurrection and flat Earth, and I think flat Earth is addressed. If anybody really wants to see what I have to say about flat Earth, it's worth having a look at my blog post called "DJ Spin That Shit," which you can find on my blog, obviously. But this thing about the resurrection. Somebody say, does thermodynamics not show it's evidently not true? Well, no, it doesn't. Apart from anything else, thermodynamics, the laws of thermodynamics are experimental laws. We can't really say much about how they hold. We can say, this is what we observe energy to do. And this is how we observe motion, which is what thermodynamics is. But as I said, Heisenberg's uncertainty principle could actually provide a mechanism for resurrection. Simply because somebody could die. We know that we can defibrillate. Yes, somebody has a heart attack. We can defibrillate and bring the heart back to life. Quantum fluctuations can do that as well. You see?
Yeah.
So, and I think anything rooted in thermodynamics is going to run into problems. I think once you pass a certain point, thermodynamics would definitely say you can't. But that's basically because the energy of life has dissipated to such a degree that you can't put enough energy in to bring it back to life without essentially destroying the corpse. But
No.
So I'm having a bit of fun there, really, you know.
And there's this little problem that if the brain has been dead for 3 days, and you
Yeah.
could get a person back to life.
Yeah, but 4 minutes of brain death and you're gone. Yeah.
Yes. So there's nothing left. You would be left with pretty much a baby in a full-grown body, I think.
Yeah.
If anything.
Yeah.
So any other misconceptions you want to touch on?
Yeah, well, I mean, I suppose while we're on while the chat is sort of centering around thermodynamics, my favorite misconception is the idea that evolution violates the law of entropy. When in actual fact it's a manifestation of it. It's entropy in action that allows for the formation of life and evolution. So yeah, I suppose that would be the one that's the one that comes up the most often, that I think is the easiest to address. But I think that part of the problem is that even people who understand entropy don't have a visceral grasp of it. I think a lot of that is because there's this notion of what entropy is, because physicists, when they write books about it for the public, they simplify it. So everybody thinks entropy is disorder, and it really isn't. Disorder, it can be a manifestation of entropy, but you know, in the same sense that all ducks are birds, but not all birds are ducks, you know. So disorder is highly entropic, but entropy is not disorder. And the idea that you can't get order with an increase in entropy is nonsense. Because, for example, the easiest way to dispel this is with another analogy, or not even an analogy, a direct example. So a drop of water, yes?
Mm-hmm.
A drop of water is lower entropy than a snowflake, yes? Would you agree with that?
Yes.
Yeah, the snowflake is more ordered. Would you agree with that?
Yes.
So there you go.
It has a clear visible structure, and so yes.
Indeed, but the snowflake has a higher entropy. So entropy increases for the snowflake to form, even locally. And this isn't something where we have to input energy. We actually have to input energy to get the snowflake to a drop of water again. And that's how you tell the difference between high entropy and low entropy, because heat can only flow in one direction unless you put if you put that in. So there's a good question. Rene's asked, does the second law of thermodynamics rule out an eternal universe? And the answer is no. What the second law of thermodynamics actually does is it says that over time, the energy that's available for performing work. You remember when we were talking about the rubber band and the differential?
Yeah.
Yeah. That over time, those differentials will tend to equalize. Now, there is something that kind of changes the game, because people will have heard about the heat death of the universe. So that's the point at which all differentials have equalized. But the problem with that, of course, is that we live in a universe that's expanding. So the point of equilibrium is going down all the time. Yeah.
Mm-hmm.
So what's actually happening with that expansion, with the cooling, is we have warm spots in the universe, we have cold spots in the universe. The expansion is making it all cooler. So actually, the point of equilibrium keeps going down. If we lived in a static universe, the second law of thermodynamics would create big problems for an eternal universe. But in an expanding universe, it doesn't. And also, we don't know what mechanisms there might be to bring us back to a state of low entropy. Roger Penrose, a few years ago, wrote a paper that suggested that under certain conditions, low entropy and high entropy would actually be indistinguishable, but they'd be the same thing. And it's also possible that supersymmetry will sort some of this out if it's ever confirmed. So yes, the short answer is no. The second law of thermodynamics doesn't rule out an eternal universe. And in actual fact, I would say that when you're talking about the universe at all, thermodynamics isn't the right frame. The universe as a whole, thermodynamics isn't the right framework to be using. Any argument that you use for example, for a beginning of the universe using one law of thermodynamics will be flatly refuted by another law of thermodynamics. Yeah. So the first law of thermodynamics, for example, says that energy may not be created nor destroyed. So energy is eternal. But the second law of thermodynamics says that energy becomes unusable, which basically means that they're at odds with each other when we try and apply them to the universe. So we have to be careful only to apply thermodynamics within the universe to things that happen in the universe, and not to the universe as a whole. The other thing is, from the perspective of thermodynamics, is that what defines a thermodynamic system is its boundary. So there are three types of thermodynamic system. There's an open system. An open system is defined by having no boundary. So that's what its boundary condition is. It has no boundary, and this is closely related to the cosmology that Hawking and Hartle have been working on. Then there's a closed system. A lot of people make the mistake this for an isolated system. They say, they talk about closed systems as if there is no energy transfer. But actually, closed systems there are quite a few different types of closed system. There's one with an adiabatic boundary, which basically means that work can cross the boundary but not heat. And an adiabatic boundary is one in which heat can cross the boundary but not work. And a rigid boundary is one in which work can cross the boundary but not heat. Yeah. And then there's an isolated system, and an isolated system is one in which no energy can cross the boundary in either direction. The problem with that is that, as far as we know, there's no such thing as an isolated system. We have to say that we have to treat it as a system because it's defined by a boundary. But in actual fact, the only thing that might be an isolated system is the entirety of the cosmos. But everything is transparent to gravity. So gravity can cross all boundaries, which basically means that work can cross a boundary. Yeah, does that make sense?
Yeah, that makes sense. And
so there you go, thermodynamics in a nutshell.
and there's another question I want to ask you. The universe is expanding; it's still speeding up. Does that really rule out a collapse of the universe in the future?
It does, yes. It does, yes. I mean, in actual fact, it was long thought that it would collapse, and it was only a few years ago that a team, I think it was Saul Perlmutter, who and a few others, who went out and did some observations, because they were saying, so the idea was, here's the hypothesis, that with the amount of gravity, with the amount of mass in the universe, the expansion should be slowing down. And if we can work out by how much it's slowing down, we should be able to see whether or not it can break free, you know, whether or not it's going to collapse, and when, how long it will last, and so on. So they went out and did the observations and discovered that it actually started accelerating about 5 billion years ago, or thereabouts. So you can see that, like, there's a distinct change where you go beyond a certain point and Hubble's law holds, but then inside, you know, before that, there's this gap where there's a sudden bit where everything's moving away even quicker. So, although it isn't moving, of course. So yes, once dark energy takes over, it pretty much rules out cosmic collapse. So we're pretty confident now that what will actually happen is, over the course of the next probably trillion years, that it will just continue to spread out, and eventually all matter will break down, all energy will break down, and you'll just be left with a sea of photons, radiation, basically.
And that, for me, is something I can not imagine. So
but the other thing is that because so under eternal inflation, so you know about the distinction between expansion and inflation, yes?
Yes.
Right. So under the inflation model, the universe underwent a period of very, very rapid inflation early on, and then settled down to a more sedate pace. And this solves various problems with the classic Big Bang model. So that's been around since about the 1980s. But there's actually an extension of it now called eternal inflation. And we need new physics to describe it, but there are actually solutions to general relativity that could account for this. So the idea is that the cosmos is expanding all the time at a ridiculous rate, and that what happens is little bubble universes pinch off from what we call the bulk, which is like the bulk is the entirety of you know, what lies outside our expansion. So that's expanding at some rate, and it may well be that dark energy is just the expansion of that bulk, you know, moving at that inflated pace, that our little bit pinched off and started expanding at a slower rate. Yes. And then as the mass gets more and more dilute, there's a pull on our universe to make it accelerate even faster, because it wants to go the same, because there's a differential between our universe and what's outside, because we're expanding slower than that, and therefore that's pulling out. So it may be that the default state of the universe is this ridiculously rapid expansion, and that we just pinched off from a bit of it, and that this happens all over the place, and possibly even an infinite number of times. I've got to the end and realised I wasn't sure whether I'd covered all the bases there.
It still is something I'll have to mull over a couple of times to
yeah.
It's pretty much the same as the state of nothing. It's not something you can you can easily imagine. I think physics can make it visible,
Yeah,
but it still is a
and that,
concept.
yeah, and that's the problem. And I remember there was a fantastic documentary by the BBC many years ago about Richard Feynman, where he was chatting. It's called The Fantastic Mr. Feynman, and I highly recommend it to anybody who's listening. And the journalist who was conducting the interview said to him, "Fucking magnets, how do they work?" Or, words to that effect. And Feynman said, "I can't actually tell you because we explain things in terms of things that we already understand, and this doesn't. There's nothing that I can compare this to that you understand that will make it make sense. So I can't, there's another classic example is about wave particle duality, yes?
No, that you'll have to explain.
Right. Okay. So, what wave particle duality is this idea that for example, we long thought that light was made of particles. Newton had this light corpuscles, he called them. So they're basically particles of light, but they behave like waves. And for a long time, Newton was kind of overthrown with this wave theory of light. And then Thomas Young did some experiments that demonstrated categorically that they were lights because they exhibited interference. You'll have heard of the double slit experiment, yes?
No.
You've not heard of the double slit experiment? Oh, right, okay. And what I'll do when we're done, I'll link you an article that you might want to make time to read. It's very, very, very straightforward, and it deals with all of it. And it also deals with it's actually a breakdown of Lawrence Krauss's book, A Universe from Nothing. And it kind of deals with all this, and it's got diagrams and shows how it all works and everything. So basically, it turns out that we think now of the popular conception is that we have these things that light is both particle and wave. And in actual fact, that's purely an explanation and not actually the way it is, because it's not. So waves, for example, waves are distributed. Yes, so waves have distribution. They cover distance, and particles are localized. So particles don't exhibit interference because they're localized. Waves do exhibit interference because they're not localized. They're spread out. But when we fire one particle at a time through the double slit experiment, we see an interference pattern that's characteristic of waves. So we think they're particles, but the behavior they exhibit is waves. So they're not particles or waves. They're electrons. Yeah. So we try to explain them in terms of things we understand, but they're actually not things we understand, if you see what I mean.
Yes. Well, I think the most fun part of light I ever came across was that it's invisible. And when
Yes.
you tell people light's invisible, they look at you as if they see water burn. But it's an easy experiment to show that it's invisible by having someone around the corner hold a candle, and someone in front of him will notice the light of the candle. You being around the corner will notice nothing.
Yeah, and actually, it's even easier than that. If photons weren't invisible, then we wouldn't be able to see anything, because there are photons flying in every direction all over the place. If you could see photons flying across the room, you wouldn't be able to see anything else in the room, would you?
No. Oh, you have
You
a
can
very
only
good
see
point.
you can only see the photons that are incident on your eyes.
Yes. And well, I think it's just a fun concept to tell people that light's invisible, and I think the same things apply to colors, at least in at some point. It's something I came across. I think I've linked you one time to Bought to Bits, and you watched a couple of
Yes.
the videos he had on there. He had a car. What color is it? The car was black, and yet you saw the car in different shades of purple and orange, and it's another thing that's very difficult to wrap your head around, that a color isn't always a color.
Yeah.
It can be a refraction.
Well, yeah. Well, actually, what we see as color is just the wavelengths that haven't been absorbed. So, yeah.
Yes, but it can come about by refraction and not by a surface actually absorbing other colors.
Yeah. Yeah.
Well,
That's right.
I think we're completely off topic now.
Indeed, yes. Easily done.
Yes. When we talk about our universe, let's touch on travel and how travel would be possible by what has been proposed, bending the universe and going from one spot to another.
Wormholes.
Do you? Yes. Do you have a simple way of explaining that, and if it's possible or if it's not possible, or because I think that
there are several things to think about. First of all, there's the technical aspect of it. So it's a good bet that wormholes exist. That if string theory is correct, then there's an even better bet that wormholes exist, because these compactified dimensions are something that you could travel through essentially. So if there's another dimension, that dimension exists at every point in the universe, but it's compactified. So there's actually a short distance between here and there to every point in the universe, if that's true. However, the technical challenges are not insignificant. First of all, wormholes probably exist now, but they're less than particle sized. We think that particles actually travel through wormholes all the time. It's possible that differences in charge on particles. So we have, you know, about an electron and a positron, yes, are the same particle with opposite charge.
yes.
Yeah. So it could be that Richard Feynman thought that actually that an electron was a positron traveling backwards in time. And this was how he came up with Hawking radiation as well, before Hawking did, but it was never made explicit. But it's certainly possible that microscopic microscopic wormholes exist all over the place, all the time. But getting one to the size that you could get a spaceship through it is going to require some extremely exotic energy, and they're going to be incredibly unstable. So I think from a practical perspective, I think it's unlikely that we'll ever be able to travel through wormholes. In terms of the actual, you know, whether physically there can be a shortcut from one place to another in the universe, I think that there's good physics to support it, but that not all of that physics is established yet. So I suppose, I guess what I'm really doing is I'm hedging my bets. I don't think it'll ever be possible for us to take a spaceship through a wormhole, but I do think it's possible that that they do exist.
Yeah, well, it at least to me it would be something I'd like to experience in my lifetime. But you just crushed Stargate SG-1 for me.
Yeah, yeah. To be honest, I've been saying since. I mean, I don't actually know how old you are, but I was born a month before the moon landing. So I've kind of grown up with this space thing, this space bug. And I thought when I was a kid that we'd already have colonies on Mars by now, and we haven't even been back to the moon.
Yes. Well, I was born in '62.
Right.
So
Yeah.
I caught some of it as well, and I miss that period. I think because it's something so incredible. The fact that we can actually put people there, and now thinking about putting people on Mars is I think is exciting. I don't know if it's going to happen anytime soon.
Yeah.
But the fact that people will be going there, and at least people have signed up to go there,
Yeah.
I think is kind of nice. And what we haven't touched on yet is possible life, and will we encounter that?
And that's one of the burning questions for a lot of people. I mean, I think that extremely unlikely that we're alone in the universe. I don't know whether there would be intelligent life. But I think it's vanishingly unlikely that there isn't some life somewhere in the universe. I mean, we know, for example, that amino acids form in space. We've observed amino acids, including adenine, which is one of the bases in the tails of comets. So we know that the very basic building blocks of life are actually out there in space. So the idea that we would be the only life in the universe is ridiculous as the flat Earth to me. But whether there's intelligent life or whether there's another technological species is an entirely different matter. And this is another one that I've done a blog post about called "Where Is Everybody?" Is that what I called it? Yeah, "Where Is Everybody?" And it was basically a breakdown of the Fermi paradox and the Drake equation. That's well worth having a look.
Yes, well, I think at least to me, it's impossible that there isn't any intelligent life. If you look at how old the universe is and how old Earth is, there have to be planets that have formed sooner and have developed life. I think it's virtually impossible that it didn't happen.
Well, I don't know about that. I mean, part of the problem is that everything heavier than beryllium, and there was very little beryllium around even, but everything heavier than beryllium had to wait for the deaths of the first generation of stars. Now, some of those stars will have been extremely short-lived because they'll have been very, very massive, and they'll burn their fuel very, very quickly. I would have thought, in a matter of hundreds of millions of years, possibly we would start to have things heavier than beryllium. But the problem is, of course, that getting the distribution right for some of those is going to take a long time. And I wouldn't be surprised to find that there was life in the universe elsewhere. But you have to bear in mind that intelligence is a strategy. It's not a requirement. the vast majority of biomass on the planet isn't intelligent in the same way that we are. Intelligence is just our strategy. We think of it as special because it's our strategy. And of course, we're not the only intelligent species on the planet. We think we're the most intelligent because we're very impressed with ourselves. But the reality is that there's nothing special about us, and there's nothing special about our strategy. It's just that it's ours, and that's why we see it as special. And there are many, many, many workable strategies that don't require intelligence or opposable thumbs. And I think you need both of those in place.
Well, when you look at, for instance, how orcas hunt,
yeah,
I think that's a clear sign that we're not the only intelligence, because
oh, absolutely. Well, not just orcas, all dolphins, all of that entire dolphin family do.
Yes.
You know, in actual fact, some dolphins exhibit even more intelligence than orcas in that respect, because I don't know whether you've seen it, but there's a great bit of footage of dolphins using silt as a wall. So they trap a load of fish by basically battering their tails against the sea floor and kicking up a load of silt, and then they have this ring of silt, and the fish won't go through it, so they just sit there, and then the dolphins just go in and have their way with them.
Yes. Well, I think one of
incredible degrees of lateral thinking. But yeah, the whales beating their tails and kicking up a wave to knock a seal off an ice shelf and that sort of thing.
Well, the most impressive thing I've seen is a couple of them teaming up together and creating a huge wave, where a seal is sitting on a larger piece of ice to get that overturned, and that at least involves communication to align up at the same time, to be knowing what you are going to do.
Yeah, lateral thinking and planning for the future.
Yes. So to say that humans are the only ones, I think it's more the fact that there hasn't been that much research on what intelligence do we actually have on the planet.
Yeah.
Than anything else.
Well, I think, you know, there are other things that we think of as not intelligent that probably are. Bees, for example, and ants and termites have a sort of a hive intelligence.
Yes, and bees have at least some sort of language. It is by motion. It is by some kind of dance they do to explain to others where food can be found. But it would need quite a lot of intelligence to be able to do that.
Yes. Yeah. But, you know, still the vast majority of the biomass on the planet is definitely not intelligent. So you know, even if you pull all of those examples out, we still would constitute something of an anomaly by biomass alone. And I think I think it's entirely likely that there's intelligent life out there, but I don't think it's as improbable that there isn't, that as you know, as we might think. I think we have to be careful, is what I'm saying, of looking at particular characteristics and saying, well, you know, this is what we would expect life to exhibit. Every time we've tried to pin down what is possible with life, we've got it wrong, you know. So
yes.
So, you know, well, I like to be careful about such things.
Yes,
it's fun to speculate, though, of course.
For quite a time, I was heavily into to UFOs, and that could have been possible, until the fact that I realized that if they are coming here across the universe and then end up abducting Billy Joe Bob from America and to insert something in his anus, I then everything broke down because
Yeah. Well, not to mention
and
that it wasn't until we went into space that we started getting these stories anyway.
Mhm.
You know, it was, you know, the dawn of the space age was when we started talking about aliens with any regularity.
Yes, and I think Hollywood had quite a hand in that by producing the first science fiction movies,
Yeah,
and there's an evolution, I think, since Close Encounters. the the regular alien has become the one that has been shown in Close Encounters. At least you can see that from there on. The little
yeah,
gray alien.
yeah, and it's completely ridiculous as well, because if there genuinely was life out there in the universe, why would we expect it to be humanoid?
Yes.
And you know,
Well,
if you look at some of the life forms that have existed here on Earth over the ages, you know, if you look at, say, Hallucigenia, have you seen that?
no.
Right. It's worth. I'll put the name in the chat, and you can kind of Google it yourself. But yeah, yeah. Go and have a Google for an image of that, um, and you'll think, wow, that looks really alien. It's bizarre, but you know what is bizarre? What does it, it's only bizarre to our senses. You know, if you look at the deep sea isopod and things like that. Um, I'm just spitballing, to be honest, because biology's never really been my thing. I know a fair bit about it, but you know, looking at animals isn't really my thing.
It isn't.
No, I mean, I take a passing interest when somebody has something to say about them, and I look at the pictures, but it's not something I've done a lot of research on. I know about, you know, I've done a fair bit of research on evolutionary theory, but not the specifics, more the mechanics of it, because physics is my thing.
Yeah. Well, I think we all have our favorite subjects. Although I have a broad general interest, which probably keeps me from getting uh, a, a good a sense of knowledge of one particular thing. Uh,
Yeah.
so that's why I like
Well, I mean,
talking to
I
different
started with
people.
physics. Yeah, I started with physics, and just on chance, um, um, my wife brought home some books from the library for me once, and she brought The Selfish Gene, and I read that, and I was fascinated by it. But that's because it's about the mechanics of it. It's like biology for physicists, if you like. Um, so that interests me, you know, the mechanics of it. Um, but I actually only know as much about evolution as I do because of debating creationists.
Yeah. Well, I have to
Because
say,
they very rarely want to talk physics and cosmology, which is my area of interest.
that's my interest got going for that by watching Kent Hovind,
Yeah,
and with the little knowledge I had back then, uh, I started to delve into that.
yeah,
I just googled hallucigenia, the worm with the missing head.
yeah.
That's what. And can you tell me what you found that special about it?
Well, I mean, just the body form. You know, if you think about, we sort of have these visions of aliens, and they're all, you know, if we think that if aliens are intelligent, then they're going to be vaguely humanoid, and it's really our own thinking. You know, it's you know, in actual fact, when we had our first pictures of this, when people did their first impressions of it, they had it upside down. They didn't even know which way up it went, you know.
Yeah, but isn't that um, aren't humans prone to do that? To if they imagine anything, it has within their own tiny box of thinking.
Yes, yes, and that's what I'm saying. That we, you know, we have to guard against that to some degree.
But it's a, a tricky way to break out from that, I think.
Yes, it's not easy, but you know, we kind of have to.
But to go back on topic, what do you think? Are we going to find life on Mars, or maybe that
I
it?
think we'll probably find extinct microbial life on Mars. There are things that have been detected that you know, we know that the only way we know of that they can come about is via organic processes, via life processes. So you know, I think it's highly likely that we'll find evidence that there was microbial life on Mars in the past. We know there was flowing water, for example. We know that there are things that we found on the surface that where we've encountered them here, they only come about via life processes. Let me see if I can come up with an example, because I'm being a bit vague here, and I don't like to be vague. Um, uh,
Well, do we know for a fact that there isn't water anymore on Mars? Because
definitely water there
as
still. It's unlikely that there's liquid water simply because it's too cold. Um, it's, for example, we know that there is ice at the poles.
yes, but what uh, do we know about beneath the surface? Shouldn't Couldn't there be a probability that there is still liquid water beneath the surface, for instance?
Um, okay, so there are like silica outcrops on Mars that look an awful lot. Oh, hello.
Yeah.
Is that is that music on my end? Oh yeah. So I've just opened up a page and a video started playing. Shut up. Right. There is evidence of biosignatures which look a lot like stromatolites that we find here. So basically what happens is that sediments react with calcium carbonate in water, and it makes a buildup of limestone. And they found sort of similar structures on Mars, in El Tatio, in the
Uh,
Gusev crater on Mars.
and what would be the most reasonable conclusion there? That it originated on Earth and on Mars separately, or that it somehow traveled from one planet to the other?
Well, that's difficult. I mean, I think one of the other problems I have in the whole discussion that centers around life is that we think of life as being something special, and really we treat it like it's a thing, yeah, like it's a property, and it's neither of those. It's a behavior, so it's something that matter does under certain conditions. So I mean, for me, a lot of the discussion becomes really about quite, and of course, it's one of the things that frustrates me so much about discussions with creationists, because it's all like, well, you don't know the origin of life. Well, life is just a behavior. What's the origin of walking?
Yeah.
Because we think of it in fact, one of my most recent offerings was about this, that we're committing this serious category mistake when we treat life as if it's a thing or a property or something that has to be conferred on something, rather than it just being a way that matter behaves under certain conditions. And as I said, we know that the basic building blocks of life form in deep space. We know that happens because we've seen it. We've seen amino acids in the tails of comets. And once you've got amino acids, and they can, and they can kind of, in relative abundances, can form long chains, then you pretty much, life is the next step. It's the next behavior it'll undergo. And it's all about, and again, it's all about entropy. It's all about things trying to get to their lowest energy state all of the time, and that's what drives pretty much every process in the universe.
Yeah, well,
I don't know if I actually answered the question there, or whether I just danced around it.
At least you gave me a lot of stuff to think about, because I have to be honest, I haven't seen life as a behavior, but it makes a lot more sense.
Yeah, and consciousness as well.
Then
Consciousness, mind is another one. We treat it like a thing, and it's not. It's just a way that matter behaves under certain conditions. Yeah,
it would at least make a lot of more sense, and I think that's something I need to delve in a little bit more, because
it's the complete solution to dualism. And dualism is one of the most pernicious ideas that floats around. This idea that mind is made of some stuff, when actually it's just a behavior of other stuff. It's the way other stuff behaves. So you get a significant number of neurons and a significant number of synaptic connections between those neurons, then that's how it's going to behave, and it's going to process information, and that's it, really. There is no great mystery in either life or consciousness that require any magic or any of that. They're just behaviors. Do we look for a solution to the mystery of snowflakes? No, because we understand that we can actually reduce it to mechanical. We know why they're six-sided. We know why they bond the way they do and form the shapes they do. It's because of the angles of incidence of the hydrogen atoms on the oxygen atom. They sit at that sort of angle, and that promotes six-sided structures because of the way they bond together. There's no mystery. It's just a behavior. Yeah.
Yeah.
So that's how I view all things, really. It's this is how humans behave.
Yeah. Well, I have to mention it, because it's not something maybe you're aware of. This is the second talk for me with a Mancunian in 1 week.
Oh, why? Who else did you speak to?
I spoke to and he's a very nice guy, and all I can think of now is that you two meet up sometime, because you live in the same city. He goes on Twitter by Diplomat655,
right?
And he's a creationist.
Ah, we have a creationist. I didn't know we had any in Manchester.
Yes, you do, and a staunch one at that. But he's a genuinely nice guy to talk to.
I have come across him before.
Yes. I have to say, he's at least one of the few that preach about Jesus and actually tries to get people together. I
I
don't
have a
think.
suspicion. Let me just have a look and see. Oops. Spelled my own name, not good. Let me just have a look, because I remember now having a.
Yeah, I think close to 2 hours talking to him, and pretty much at the end of the conversation, I found out that I had my recording software running twice, and that gave a conflict about I think an hour and 12 minutes into the talk, so it stopped recording, which
I remember him now. I remember him. Yeah, we didn't have a good interaction at all. He basically asserted that faith is a requirement, that nobody can live without faith, and then tied himself in all sorts of pretzels. Back in January, I interacted with him. All sorts of pretzels, and it basically ended up being incredibly dishonest with me.
Yeah, well, I have to say, I had quite a run-in on Twitter with him, and then
Right.
when talking live to him, it's different. The problem I have with Twitter is there's no intonation, so you can send a tweet and someone can take that completely the wrong way, which I think happens quite a lot.
Yeah.
But I have to say,
Yeah, I mean,
he's a very nice guy to talk to, and at least I would
I dare
enjoy.
say. I mean, I've just to dug up the conversation that I had with him, and basically he made a load of assertions, and I asked him for evidence in support, which is is my usual go-to, my icebreaker for any conversation on Twitter, for
Yes.
the most part. I asked him for evidence, and he just went straight into the you won't look at it shtick. Why would I give you evidence if you won't even engage it? And and I've said I wouldn't ask for it if I weren't willing to engage in it. I want to see it.
Yes.
Then he directed me to someone's book, and then he danced around, wouldn't present an argument.
Well, he presented arguments to me which I thought weren't really arguments, but just bold assertions and maybe misconceptions. But
and
if
ended up with him
possible,
just jacking off.
if possible, I would really like to see you two in a chat someday, because of the fact that at least you live close together, that would be, and yours. While we're talking about the universe, you're a universe apart in thinking, I think.
Yeah.
So,
okay. Well, I mean, so your talk with him is up on your channel, is it? Yeah.
No, not yet. I'm having trouble getting the talks rendered. I want to do them in chronological order, just because I think I owe that to the people I talk to. And the next talk I need to post is 3 hours long, and that keeps crashing on me. I have no clue why, because I have done a 3-hour talk before, and that went well. And recently, the laptop I use for that stopped working on me. I still have to figure out what the problem is, and so that's why I suggested to do this in a different way. At least I can have it posted right away.
Yeah.
And don't have to struggle. I'll try to download it and see if I can attach an intro and an outro for this. But yeah, I'm still struggling with rendering stuff.
Right.
But it'll be up.
Yeah, I wish I were in a position to help, but I'm my time is.
Oh no, that's not a problem. If all fails, then I think I have a friend who can help out, and I'll take my stuff there and have it rendered over there. So, but
yeah.
I want to do it on my own, and just not to be dependable on someone else. And it might involve that I may have to buy new stuff, which is probably necessary because I want to do talks like this and have actually have the video of both people talking, which I think would improve the talk. At least for longer talks, it's nicer for people if they can have something to look at as well. Although I'm not sure that I'm the one they want to look at, but that's a whole other subject.
I don't know. I mean, to be honest, I would have no problem sitting in front of a camera and doing these talks. The only thing is that I will, certainly. So we've been on very nearly 2 hours now, and I wouldn't have been able to go away and have a cigarette and carry the laptop across the room with me and sit. Usually I'd have Bluetooth headset on so that I could just wander off to the door and have a smoke and so on. But I couldn't get my Bluetooth headset to connect today, so
that would be a problem for me too, because I smoke too.
I can tell. I heard you.
Yes. So I think I'm going to adapt the Hitchens way, because I think didn't I see him smoke in talks?
He did used to, yes.
Yes. So if that's if those are footsteps I can follow, then I'll take that. I'm not that eloquent as he was. I'm not even that smart, I think, as he was, but at least I can
I think that you're a lot smarter than you think you are, and that you really shouldn't think in those terms anyway. I think that there's a difference between being smart and having a lot of knowledge. Hitchens was incredibly intelligent. There's absolutely no two ways about that. But an awful lot of what he was knowledgeable rather than. I think that there's this thing that we are. We have this thing about intelligence that, and I get it all the time, and I don't think it's warranted. I think that I've read a lot of the sort of things that people generally don't read, because the sort of things that I read are not popular, and then the sort of information I'm interested in is not that popular among people. And I think that people think that if you can talk knowledgeably about these topics, then you must be really, really intelligent. But at the same time, David Beckham could talk really, really knowledgeably about kicking a ball, but that's not considered an intelligent topic. I think that an awful lot is made of differences in intelligence levels that really doesn't stack up, to be honest.
No, and I like to think that at least being open to learn new stuff and to keep learning, even
yeah, and that's part of what intelligence is.
Yes, and well, as you said about David Beckham, if you really boil it down, he's talking about physics as well, because if he's talking about
Yeah,
kicking a ball, there's a lot of physics
indeed.
that come into that. If you look at in Britain, the snooker players, they need physics. So um, people might see it as maybe as less intelligent, but there's a lot of intelligence coming into it, and it's a specialty
Yeah,
um, that people have. Um, but I want to conclude it. We're on 2 hours now. I think that's a good chunk to put out. Uh,
indeed.
I think if we go a lot longer, that we at least lose people listening in. Um,
Hmm.
as always, I enjoyed the talk immensely, and I hope we can do it again.
Yeah, yeah. It was good fun. And maybe
Um,
we'll move on to some of the topics that you know more about than I do, because we haven't even explored what they are.
um, well,
Apart from graphic design and that sort of thing.
cars mainly. I'm a car fanatic.
Cars,
Since
right?
yes, since I could talk, I'm a car fanatic. Although I have
Right.
to admit that the newer stuff is something that uh, I've lost touch with. Um,
Right.
I don't think it's that interesting. I like the older stuff. So, but that's something
It
we
depends.
can't use.
Have you seen that McLaren hybrid?
No.
Oh yeah, you definitely need to go and Google that. Top Gear did a short film on the new McLaren hybrid just before the famous punching incident, um, and it's available on YouTube. You should definitely go and have a look at that.
That's the old series of Top Gear.
Yeah.
Yeah, I have. I still have to watch the last season. I have
Well, I
every
haven't.
single.
I watched the first one with Chris Evans, and then I abandoned it. I've watched it since. In fact, I remember the old series, the original Top Gear.
Yes.
Used to watch that. Used to watch that when I was younger. Um, and I'm not hugely into cars. I in fact don't enjoy driving anymore. Haven't done for a very long time, but I think it's because I did a lot. In my first 10 years of driving, I was working the clubs all over Europe, and I was spending sort of 8 hours a day on motorways and autobahns, and you kind of the novelty very quickly wears off when you're spending that much time behind a wheel and not if I was on a racetrack having fun blind around, then probably I'd still enjoy it, but but no,
That
I don't get anything out. But I found it really funny. Found it really entertaining just watching the three of them doing daft
yes.
stuff in cars all over the place.
As I said, I have every single episode, so I can still go back to what is it, 2000 when they started,
Yeah, when they started
and
again. Yeah,
and I sometimes, because I just like, I'm also addicted to British humor. I think you already got that by
yeah,
me tweeting stuff from Are You Being Served and stuff like that. So that's where I relax with all the old British comedy.
yeah.
But we can figure out another topic. Um, I recently spoke to uh, Jackson Wheat, who did
Oh yes,
the
what a lovely
concept.
guy he is as well.
Yes, and you said you would like to have a chat with him, and I think that's something that should happen. And I don't know
Yeah,
if
yeah,
you both
definitely.
agree, but I would very much like that to be a public talk, and maybe set it up and just pull my mic and let you two go at it, because I think that would make for a very interesting talk.
Yeah, I think so too. I mean, he's clearly very knowledgeable, and And in actual fact, I did say to him, and I haven't got around to doing it yet, because I've got so much on at the moment, but I still intend to do it. But I did say that I'd do a review of his debate with Kent Hovind, because just in the first few minutes that I managed to watch, I spotted, like you, I've been doing this a very long time, and also I have a knack for seeing the hidden fallacies and that sort of thing. I'm actually one of the other I have about 25 half-written blog posts at the moment and I really must sort of start getting on and finishing some of them. But one of them is about hidden fallacies. The fallacies that are lurking beneath the surface that aren't always obvious until you know where to look for them. Because I think that's the one thing I think I can bring to the whole rationalist debate that isn't currently there is when somebody makes an assertion about something and you can backtrack the reasoning yourself without having to have them explain all their reasoning to you to see where you got to them. So most assertions are rooted in most creationist assertions are rooted in a fallacy known as affirming the consequent or some other hidden fallacy. Begging the question is an obvious one. That's one of the ones that people can tend to spot where you make an assertion that relies on the truth of some unstated proposition for it to be true and for your reasoning to be valid, but you without seeing the unstated proposition. I think most people can see begging the question, but there's a whole class of fallacies there that aren't as obvious as that. And in fact, even some instances of begging the question and circular reasoning aren't that obvious. So there's a whole class of fallacies I want to address on the blog there, because that's actually where most of the blog is going now. It seems to have gotten off scientific topics and seems to be focused more on sort of the logic of discourse and that sort of thing, and how to spot fallacies. And because I think that's the unique thing that I can bring to the table, just because I've done it a lot,
Yeah.
So.
Yeah. Well, so I hope that that'll happen soon, and make it public. I'd love to help out and to set it up. So we'll leave it at there, Tony.
Yeah.
I had great fun talking to you again, and I hope people will like it. We'll see.
I did too. Always a pleasure, Peter.
Okay. So I say until next time.
Indeed. And we'll do it again. What great fun. Thanks very much for listening. Thanks to everybody else for listening, and thanks for the chat. It was good.
Yes. Thanks to I have to do that to the people in the chat and to throwing in a couple of questions, because I'm still struggling with moderating a talk sometimes, and I like to at least learn in that fact. So this is a great help.
Absolutely.
Tony, thanks, and we'll talk next time.
Take care, mate. Speak to you soon. Bye.
You too. Bye-bye.